Hello there! I have a design idea that I want to share. It's basically a custom wireless power transfer coil production method. Yes, it's a mouthful. And essentially, it's just a Litz wire encased in resin. As you can see, it is double layered. The lower layer is transparent. It's just for the looks of it. But the upper layer is ferrite dust and resin composite to increase efficiency. Here are the other variants. Of course, it will never be as good as an actual ferrite, because the amount of ferrite particles per cubic football field will always be lower due to resin and loose packing of dust particles. But as you can clearly see, it is fairly magnetic, considering the dead weight of resin and inconsiderable copper diamagnetism. The biggest advantage of this method is the relative ease of production, but on a limited scale, and also the ability to vary the magnetic coercivity of the back plate by increasing or decreasing the ferrite dust concentration. You can definitely make it thinner, but I have ordered the slightly wrong Litz wire diameter. This is way too thick for my application anyway. But on the other hand, you can increase the efficiency of the power transfer system by increasing the thickness of the ferrite plate, as far as I'm aware at least. I have not done actual calculations on this part. I also want to demonstrate it. I hope it works. This is by far not the perfect setup because I am using my cubic signal generator for this, and it has a DC offset of 2.5 volts on the output. Here, in the top right corner, you can see the voltage graph on the primary coil. It is in blue, and in yellow you can observe signal on the secondary coil, as I bring my secondary coil closer to the primary. And you can observe the yellow line getting bigger. Yes, it is hot garbage, quite literally, because it is basically a short-circuit inductor after each pulse, but I was too lazy to look for a tank circuit capacitor. We can even connect an LED to the secondary coil and see some flickering perhaps. Let's try it. And yes, it lights up. I am planning to make the whole power transfer system work in resonant coupling. For now, it's just inductive coupling. Resonant circuits should increase efficiency and maybe even increase coupling distance. This is where the second disadvantage of this coil production method comes in. It's really hard to make identical coils by hand. In theory, you can make a special jig to coil the wire and carefully weigh ferrite resin. I just didn't do this. All these coils, according to my preliminary measurement at least, are around 1 microhenry, plus or minus 50 or 30 nanohenries respectively. So it's a 5% deviation at most, which is okay, I'd argue, and the measurement error is probably way bigger than this deviation. That's everything about the coils. I am not claiming my authorship over this production method. I am pretty sure someone somewhere did a similar thing, but I hope that you personally learned something new today. But this power transfer system still needs a lot of development, such as capacitors for the resonant circuit, an edge bridge for the primary coil, and an AC-DC rectifier for the secondary, and perhaps even some capacitors for the voltage ripple reduction. And as always, thank you for your attention and see you next time.